Welcome to Physics Made Easy channel. And first, I will revise a bit from the previous section so that we can catch the lines. We have done electric field. Now, when electrons actually they diffuse into this region and holes diffuse into this region, as a result, depletion region develops as we have discussed in our previous lecture. Positive charge is localized on N site and negative charge is localized on P site. As a result of this bound positive and negative charge, potential difference develops. And due to potential difference, electric field develops. And electric field is this potential difference divided by distance d. This distance d is of the order of 10 raised to power minus 6 meters, and potential difference is of the order of 0.5 volt, and this comes out to be 5 into 10 raised to power 5 volt per meter. This is the electric field developed. Now the barrier width is 10 raised to power minus 6 meters, and barrier height, the difference of potential from one side to the other. This represents the voltage. Voltage is highly positive on this N side and negative on this P side. So this is the variation of voltage and charge, positive on this side and negative on this side. And if I have to write this in this way, so this is N side, and this is P side. This is P and this is N side. On N side, we have got positive charges, so it is in the positive half of y-axis, and this is in the negative half. So on this side we have got predominance of negative charges. So this is how these diagrams have been drawn. The barrier height we have discussed in last lecture, and next the drift current. Now here we have got a potential difference. Under the influence of this potential difference, drift current develops. Drift current flows under the influence of electric field across the junction barrier. An electron on the P side of the junction moves to N side. A hole on the N side of the junction moves to the P side of the junction. The motion of these charge carriers due to electric field is called drift. Drift current is in opposite direction to the diffusion current. So in equilibrium state, as I have stated in my previous lecture, that with the passage of time, drift current ID, it grows up from 0, and diffusion current I diffuse, it goes down from maximum towards 0, and this goes from 0 to max in this way. IH drift is equal to minus IH diffusion. This is for holes. Same holds true for, you can say, electronic current. For electrons, IE drift is equal to minus IE diffusion. This takes place in which case? In equilibrium state. In equilibrium state, this happens. I drift current is equal to I diffusion. I hole drift is equal to I hole diffusion. IE drift is equal to IE diffusion. The only difference is both the drift and diffusion currents, they are in opposite direction. Now at this stage, the potential barrier, note down this line. Potential barrier has maximum value, VB has maximum value. It means the barrier voltage stops the diffusion of majority charge carriers. Depletion region is directly proportional to temperature, width of depletion region. That is X is the width of, I will write here delta X, is directly proportional to temperature. The p-n junction diode is equivalent to capacitor. This is equivalent to a capacitor. How is it equivalent to a capacitor? In which depletion layer acts as dielectric. Ct is equal to epsilon A by W. W is the width of depletion region. And next is the biasing. Biasing of p-n junction. How do we bias a p-n junction? P-n junction is forward bias if positive terminal of battery is connected with P and negative terminal is connected with N. Here, positive terminal, negative terminal is connected with N side and positive is with P. So this is the positive side of the battery. This is connected with P. This is the negative side. This is also joined with P. And holes, they drift in this direction. Electrons, they drift in this direction. This is the symbol of p-n junction. This is battery and this gray colored portion is depletion region. Now on P side, there is a majority of electrons in the depletion region. On N side, there is majority of holes. So this can be said to be negative. This can be said to be positive. Now, this decreases the potential barrier. Biasing voltage decreases if V is the biasing voltage. VB is the potential barrier before forward biasing. After forward biasing, now forward biasing. After forward biasing, we have after forward biasing, what do we have is this is basically the potential barrier. So VB comes down after forward biasing. If VB comes down, it means current increases. Simply, if VB comes down, applied voltage V opposes the barrier. Effective barrier is VB minus V. The width of the layer decreases. Yes, this question has been asked in NEET. The width decreases. The majority carriers, holes on the P side and electrons on the N side, flow towards the junction. So the conduction is due to majority charge carriers in this case. The diffusion of electron and holes into the depletion region decreases the width. This diffusion decreases the width. Effective resistance across p-n junction decreases. Resistance R across p-n junction decreases. The magnitude of the current is in milliampere. In forward biasing, note, in reverse biasing, it is microamperes. That is 10 raised to power minus 6 amperes. And now, the positive potential of P region. The positive potential of P region attracts the electrons from N region, and negative potential of N region attracts the holes from P region, like this. So this is P and N. So here we have got electrons, very few electrons. Now as this is positively charged and this is negatively charged. Now what will happen? These holes will move towards the barrier. And in this case, this is negatively charged, electrons will move towards the barrier. So this is the case of forward biasing. The result, diffusion of majority carriers across the junction, and Now, because majority charge carrier are only small, so it means current will flow only for some time and after that it will stop, but it is not like that. For each recombination that is taking place here, note it down. For each recombination that is taking place here, a bond breaks here. Whole move towards the bond breaks. Now what is important is whole moves towards the barrier and electron towards here. In this way, this equation is balanced. Now, for each electron, now if I explain it here, for every hole going there, an electron moves towards this side of the battery, this side of the battery, and from here an electron is released. From here an electron is released. An electron is released here. Now, negative charge on this side pushes electron towards this. For every electron crossing the barrier, every electron crossing the barrier, an electron from here enters. In next case, for every hole moving towards here, a bond breaks here, electron go to the battery and hole go to the barrier. In this way, this balance is maintained. Now let us read how he has written is. After crossing the junction, electron and hole will combine with each other. For each electron hole combination, note this line. For each electron hole combination, a covalent bond in P region, note down, a covalent bond in P region near the positive terminal of the battery here, covalent bond breaks. In this region, bond breaks, covalent bond breaks. Electron moves like this, as I have shown in diagram. Electron moves like this. Hole moves towards this side. Electron moves towards this side. Electron move in this way. This battery releases an electron and electron goes here. For every electron moving in this direction, an electron enters here. Here an electron enters. In this way, the charge balance is maintained. So I will exactly read the theory line. For each whole electron combination near positive terminal of the battery, a covalent bond is broken and liberated electron enters the positive side of the battery. This is the liberated electron. This enters the positive side of the battery. This action results in creation of a new hole. This is new hole and this moves towards the junction. Now at the other end, the electron from the negative terminal of the battery is released as I have shown in this diagram, and this enters the end region. This electron makes up for the loss of this electron which has crossed the barrier. In this way, In forward biasing, barrier voltage decreases, current increases. Current is due to the majority charge carrier. These are the main points. And before that, I have just this line. This question has been asked in examination. Depletion region is directly proportional to temperature. In equilibrium position, diffusion current is equal to the drift current. Drift current takes place under the influence of electric field or potential difference. And diffusion current takes place under the influence of concentration gradient. With these words, before finishing this lecture, I will request you all of you to kindly see the video. If you like, then share. If you don't like, then comment. Thank you very much.